All right, so did you guys figure out what our domain and range is? Who can tell me what the domain is in this function? Risal? X does not equal 2. Everyone understands why, right? Oh, yeah, you're right, -2. Does everyone understand why our domain is X does not equal -2? No? Okay, so the domain refers to our X values, right? Our inputs, what we can plug into this function. And you see how X is in the denominator of the function? You cannot have 0 as a denominator. That is the only restriction in this type of function. You cannot have a 0 in your denominator. So the only X value that you cannot plug into this function is what would make the denominator 0. If you were to plug in -2 for X, you would have -2 plus 2. What's -2 plus 2? 0, right? And you cannot divide any number by 0. So that is the only domain restriction that you have in this function, right? So everyone understands now? Your domain is going to be every number except the number that would make this denominator equal to 0. So our domain is all real numbers except for -2. And the simple way to write that is just X does not equal -2. Everyone understands? What is our range? Vivian? X does not equal -4, right? Oh, yeah. Y. Yep. So this is K in the function, right? K is going to tell us what our range is. So you just put Y does not equal and then whatever K is. So K is -4. So our range would be Y does not equal -4, right? What is my vertical asymptote? So that is X equals what? Vivian? -2, right? X equals -2. The asymptote, did you guys write down? You guys wrote down the definition yesterday of what an asymptote is, right?
Yeah.
So what is it?
A line that a graph approaches guide the end between the function.
Yep. So our asymptote is a line that our function approaches. It's going to be easier to look at this once we graph it. So who can tell me what the translations are for this function? Left 2, down 4, right? Everyone understands that? The translation, left 2 and then down 4. Remember, H tells us if we're shifting left or right. If H is positive, we're shifting to the left. If H is negative, we're shifting to the right. And then Y, right here, or not Y, sorry, K tells us our horizontal or vertical shift. If K is positive, we shift up that many units. If K is negative, we shift down that many units. So K is -4, so we're shifting down 4 units, right? So this is what our graph looks like. So these are our asymptotes right here, right? Because when the graph shifts from the parent function to our new function, the asymptotes shift as well, right? And the asymptotes shift in the same manner that our graph does. So if our asymptotes shifted 2 to the left, what is our new vertical asymptote? X equals what? X equals -2, right? You guys see that? So this line right here is our asymptote, and it runs across X equals -2. And what is our horizontal asymptote? Yep, Y equals -4, right? Because excuse me, our graph and our asymptote shifted down 4 units. So our new horizontal asymptote is Y equals -4. Right? Everyone understands that? Our asymptote is the line that guides our end behaviors. So our lines approach the asymptote but never touch them, right? And the reason that we have X equals -2 as our vertical asymptote is because this is where our function is undefined, right? You can't plug in -2 for X So the lines will never touch negative 2 on this line, right? Everyone understands that? Does anyone not? Okay. So now we know that our range is y does not equal -4. Our domain is x does not equal -2. Our horizontal asymptote is y equals -4, and our vertical asymptote is x equals -2. All right. This is the last example in this lesson. We're going to move on to lesson 4-2. So on your workbook, you can flip to page 100, or that's 183 on your workbook. This next lesson is going to build on our previous lesson. Oh, wrong one. We'll do this discussion very briefly, but we have 3 functions here, and it wants us to identify if the functions are linear, and if they are, we want to identify what the y-intercepts and the slopes of those functions are. So f of x is equal to net x minus 1. Is that a linear function? Yeah, right? I saw a lot of you shake your head yes. That x minus 1 is a linear function, right? If you graph that, it's going to be a line. What is the y-intercept of that function? -1, right? This is in slope-intercept form, right? So slope-intercept form gives you your slope and your y-intercept on the function. So what is our slope? 1, right? Our slope is 1. What about g of x? Is that a linear function? So graph it and see if it is a linear function. You need a calculator? It is, right? This function is the same as okay, cool. So this function right here, g of x, is the same as g of x is equal to 1/2 x minus 1/2, right? Because this this 2 is dividing into x, and this 2 is also dividing into 1/2. So it's 1/2 x minus 1/2, and that's a linear function, or yeah, right, linear function, right? So what is my y-intercept? -1/2, and what's the slope? 1/2, right? And the reason that they're showing you this is to show you that this looks like it's not a linear function, but it is. Now, this also does not look like a linear function, and it's not. If you graph this function, it is, excuse me, it is going to be a rational function, which looks just like the reciprocal functions that we were doing, right? So this is a rational function. All right, so let's move on to the next. So you can flip your page to 184. Now this tells us to do, it says rewrite g of x is equal to 4x over x minus 3 using long division. How is the quotient related to the reciprocal function? So we're going to rewrite a rational function to identify the asymptotes. Right? So we want this function to look like the other functions that we were working with. Who remembers long division? You can use synthetic division here too, but I want us to get used to long division because there's going to be a few examples where we cannot use synthetic division and we're going to have to use long division. Before we get started, because my last class, they had a little bit of a hard time understanding why we did a certain thing. So we're gonna start this off by doing a very simple example of long division. You guys know off the top of your head what 7 divided by 2 is, right? 3.5, right? 3.5, or if you write 3.5, it's 3 and then 1 over 2, right? All right, so I'm going to show you guys how you get that answer using long division. So we're dividing 7 by 2, right? All right, so how many times does 2 go into 7 evenly? 3 times, right? 2 goes into 7 3 times evenly, right? So you're going to write a 3 up here, and then you multiply what's up here, you multiply by this number and you write it down, right? Because the goal of long division is to eliminate what you have inside of the division symbol, and we use subtraction, right? So we're going to subtract what 2 times 3 is. So what's 2 times 3? 6, right? And what is 7 minus 6? 1, right? So now I know you guys are probably used to writing 0.0 and then bringing this down and writing a point right here, right? We're going to use what? On this one on the board? I'm just showing you guys a very simple example of long division. So instead of doing that, what we're going to do is this is our remainder, right? We call this a remainder, what's left over, because 2 does not go into 1 evenly, right? So instead of adding a decimal, what we're going to do is we're just going to put our remainder 1 over what we're dividing by. And that's 3.5, right? Do you guys understand? If I put my remainder over what I'm dividing by, gives me the same answer as if I did decimal, right? Because if I did decimals and continued, 2 goes into 10 5 times evenly, right? And I would have 3.5, but 3.5 is the same as 3 and 1/2, right? Everyone understands that? Okay. So keep that in mind when we're doing long division. I'm gonna go through this example with you guys. So we're dividing 4x. Let me give myself some more space. We're dividing 4x by x minus 3, right? So we have to identify how many times x minus 3 goes into 4x evenly. It doesn't, so we're just going to look at this first. We're going to look at this first variable and identify how many times x goes into 4x evenly. So how many times does 4x go into, or sorry, yeah, how many times does x go into 4x? 4 times, right? So we're going to write 4 on top. And then what's 4 times x? We're subtracting, right? So minus 4x. And then you also have to multiply this by 4. So what's 4 times negative 3? Negative 12. All right, so now we can subtract. We're going to put plus 0 here. There's nothing here, but so that we know what to do. So 4x minus 4x cancels out, right? We're left with 0 here. And then 0 minus 12, sorry, 0 minus negative 12 is the same as plus 12, right? So we're left with plus 12. So what are we going to do with this remainder? This is my remainder, 12. Yes, we're going to put it over x minus 3. So our new function is 4 plus 12 over x minus 3. Does everyone understand how I got this function right here? Now, can you identify what your domain and range are in this function? Who can tell me what my domain is? X does not equal 3, right? Because 3 would make this a denominator of 0, right? So x does not equal 3. And what is the range? Yep, y does not equal 4, right? What is my asymptote? What are the asymptotes? Those are the asymptotes. How does this function shift from the parent function? Right 3, up 4, right? Does everyone see that? It might be, it looks a little different from the function we were doing, but you can rearrange this. You can rearrange this 4 to be at the end to make it look like the other ones, because it's the same as 12 over x minus 3 plus 4. And then you can see that this shifts to the right 3, and then it shifts up 4, right? Everyone sees that? So here it's just showing us the same steps that we just did. X minus 3 goes into 4x 4 times. You're left with a remainder of positive 12. You put your remainder over x minus 3, and you have 4 plus 12 over x minus 3, or this, it's the same as 12 over x minus 3 plus 4. And then here is the graph of the function. It shifted to the right 3, and it shifted up 4. And while the graph shifted, so did our asymptote, right? So our vertical asymptote used to be at x equals 0, but then it shifted 3 to the right. So now we have x equals 3. Our horizontal asymptote from the parent function was at y equals 0, but then it shifted up 4. And now our new asymptote, horizontal asymptote, is at y equals 4. Does everyone see? Understand that? So our asymptotes shift with our graph. So you're able to identify your asymptotes using h and k. Oh. So now you guys are going to do this one on your own. This one's on your workbook. So you're going to use long division to rewrite this function. So you're dividing 6x by 2x plus 1. Did you guys figure out the rewritten form of the function? Who's got it? Nash, what'd you get?
I'm not sure, but 3 and 3 over 2x plus 1.
Yeah. 3 plus 3 over 2x plus 1. Did everyone get that?
I got negative 3 over 2x.
Let me see. All right, let's do it. How do I? All right, so we have. Can't find a blank space. All right, so I'm going to write it over here. All right. All right, so we're dividing 6x by 2x plus 1, right? So how many times, so 2x plus 1 won't go into 6x evenly, but we can look at our first term, 2x, and see how many times that goes into 6x evenly. So how many times does 2x go into 6x? 3 times, right? So we're going to write 3 on top. 3 times 2x is going to be 6x. And we're subtracting, right? So, and then what's 3 times 1? Plus 3, right? We're going to put plus 0. There's nothing here. And then now we have 6x minus 6x. They cancel out, right? That's 0. And then what is 0 minus positive 3? Negative 3. So this is our remainder right here. What do we do with our remainder? So we're left with negative 3 over 2x plus 1. So our new form is 3 minus 3 over 2x plus 1. Vivian and Michelle, is that what you said you got? Yeah. Oh, so Naj, I think what you forgot to do is, so you had positive 3 here, right? Right here you had, where's my mouse? Right here you had positive 3, but you forgot that you're subtracting, right? So you have minus positive 3, which is negative 3. So that's why your remainder is negative 3. Yeah.
We'll get 3 plus negative 3 over 2x.
Yeah, that's the same thing. But I always want to write it this way. I'm gonna write 3 minus positive 3 over 2x plus 1. But it's the same thing if you wrote 3 plus negative 3 over 2x plus 1. It's just gonna be easier to see it in this format because now we're gonna so we have 3 minus because now this tells us what our transformations are, right? And you can also rewrite this as 3 over 2x plus 1 or negative, and then plus 3, right? So for this, function, what is my domain in this function? Let's see. What is my domain in this in the new function? Which is 3. What is the domain here? It's not negative 1. Negative half, right? x does not equal -1/2. Does everyone understand why our domain is x does not equal -1/2? If you were to plug in 1/2 for x, what would you get? What's 2 times -1/2? -1, right? And then what's -1 plus 1? 0. So if you plugged in -1/2 for x, that would make your denominator 0. And again, you cannot have your denominator be 0, right? You can't divide anything by 0. So our domain is -1/2. What about our range? It equals 3? Oh, sorry, does not equal 3? Yeah, y does not equal 3, right? And I don't want this to be more confusing, but sorry, not that. This is going to tell us our transformation, right? You don't have to write it this way, but you have to know because our format is 1 over x minus h plus k, right? So if you would have said that the transformation is left one, it would have been incorrect because you have this 2x here, right? It only tells it when you have just x minus h. You have to factor out that 2, which is why I wrote it this way, 2, and then in parentheses x plus 1/2, because the translation, the horizontal translation is actually -1/2, right? So it moves to the left by 1/2. Does everyone see that? And then what is your vertical translation? +3, right? Clear. So I'm going to move this 1/2 to the left by 1/2, and then up 3. So you see that the new asymptotes are at y equals 3 and x equals -1/2. Any questions on this one? I know this one was a little confusing because we added the 2x plus 1 on the bottom. If you have a number in front of x in your denominator, it is going to change what your horizontal translation is, because in the original format it's just x plus 1, right? So having a 2 in front of your x is going to change what that format is, right? It's different from the format. All right, this next one's easier. So go ahead and do this one on your own again. So you're going to use long division. All right. Did you guys figure this one out? What'd you get, Nash?
1 negative 6 over x minus 6.
Let me check. So what did you say you got?
1 negative 6 over x minus 6.
So it's going to be 1 plus 6 over x minus 6. Mhm. Did everyone get one for the new function? 1 plus 6 over x minus 6? All right, let's do it together. I'm going to use long division again. So I have x is being divided by x minus 6, right? So how many times does x go into x evenly? One time, right? So then I do, and we're subtracting, right? Whatever our product is, we're going to subtract. 1 times x is x, and then 1 times negative 6 is minus 6. I'm going to put plus 0 here so I can visualize it. So I'm subtracting now. So I have x minus x. These cancel out. It's 0, right? And then what is 0 minus negative 6? Are you sure? Positive 6. Subtracting a negative number is the same as adding, right? Minus negative 6 is plus 6. So then you're left with plus 6 over x minus 6. You can write it as 6 over x minus 6 plus 1, if that's easier for you to visualize, or it is 1 plus 6 over x. Does everyone understand how these two are interchangeable? The position of the whole number can be at the front or at the back, right? The reason I rewrote it here is because in the previous examples, we were seeing our function written in this format, right? But they are the same function. So this one is really easy. We don't have a coefficient. Well, our coefficient in front of x here is 1, right? So what are our transformations on this function? Right 6, and up 1, right? So we have our transformations are right 6 and up 1. Right 6 and up 1, right? And so in the parent function, our asymptotes are at y equals 0 and x equals 0. With this function, since it shifted 6 units to the right, where is our vertical asymptote at now? X equals what? X equals 6, right? And our graph shifted up 1. So where is our new vertical asymptote, or sorry, horizontal asymptote? Y equals 1, right? Now that you know what the asymptotes are, what are the domain and the range? X does not equal 6, and x does not, or y does not equal 1, right? If you were to plug in 6 into this function, you would have 6 minus 6, which is 0, and you cannot have a 0 in your denominator. So class is about to end. We'll continue. This is the last example on that. We're going to move on to something else tomorrow. Tomorrow we're going to start example 3.
If you're not doing anything, all class ends, can you explain how you got the last